I said what I have with works, but so we're gonna. I think when we come back for Christmas, we'll have one. No. So we'll see. All right. So some of you may take BC Cal next year, and in BC Calculus, one of the topics towards the end of the year are Taylor and Maclaurin series, and they're really pretty cool, and they're used in a large number of applications, whether it is actuarial math, which some of you may or may not go into. My son's getting a degree in that. It's actually a pretty great way to make a low pressure, low stress living. You can do pretty well. Actuaries, they usually start you 65, 85 a year. And then your top end, if you become a fellow, which is hard to do because you have to pass these series of tests. And if you pass them all, you can make anywhere from $250 to $400 grand a year. And it's you work for insurance companies, and you basically assess risk. And it's not like super exciting, but you can do really well. And it's very low pressure. Like, it's kind of one of the few low stress jobs out there, because they just basically hire you and say, hey, go figure this out. And you come back and you go, okay, based on what I've calculated, there you go. But you can do really well, but it requires a brain that not only is mathematically sound. When I mean sound, I mean you got to be a really great math student, but you almost have to have a tinge of accountant in you too. And when I say accountant, accountants don't really need to know math. They need to be able to think about lists and the 50 ways to do so-and-so and the 10 exceptions to so-and-so, and be able to process large amounts of information and be very exact. Okay? Used to be accountants, you think math, but it's all spreadsheets now. But you have to be able to remember a lot of stuff and be able to do the math to be an actuary, which is why there's so few of them and why you get paid so well. But anyway, some of the work that you do requires these series. We're not going to really look at the series so much as one aspect of the outcome, which was how to find terms in the series. Now, this boils down to what you already know about binomial expansions. Okay, these series come from these expansions. Now, I don't know if you remember binomial expansions, but you probably do, because I used to give you some binomial, something that could be written in, say, a plus bi form, raised to some power, right? And then I would ask you questions like, determine the fifth term. You remember these? Or determine maybe the middle term, right? Or maybe determine the term with, x to the 8th in it. Do you remember all these expansions? And the way we did it is we'd say, well, on almost every one of these, we would start with n factorial, and then we would copy down the a and copy down the b, and then we just had to figure out what those two things were, remember? And we would figure out those two, and whatever went there and there also went here and here. Well, we're going to be doing that again. I'm going to remind you about it, and then I'm going to increase the ante a little bit. I'm going to make it look like not just a simple binomial expansion, but more of a Taylor expansion or Maclaurin expansion. And that occurs when this power up here is no longer a whole number. So instead of that plus that to the 8th, and then I say, what's the fifth term? I'll say that plus that to the 3/4 power. And you're like, 3/4? And that weirds people out a little bit, because you think, wait a minute, if that's a fraction, then you actually have to take a fractional factorial. So what the heck happens with that? So here's the mentality on this, and we're going to use, there really is no such thing as a fractional factorial. By the definition of a factorial, it should be a whole number, right? So if it's something like 7 factorial, you go 7, 6, 5, 4, 3, 2, 1, right? You multiply them all together. With a fraction, you run into a little bit of trouble, because in theory, if I have something like 1/2 factorial, how do I go 5, 4, 3, 2, 1? The rule is n factorial says take the n and multiply it by what? N minus 1, and then n minus 2, and then you keep on going until you hit 1. Well, with that mentality, minus 1, I end up getting 1/2 times what? -1/2 times -3/2, and what do I find myself doing? moving away from 0, right? I'm moving away from 1. So this would be an infinite series. And that's what Taylor expressions and Maclaurin expressions do. But the cool thing about them, you can actually use them to do stuff like approximating square root of 2. Like square root of 2, how would you find square root of 2? I mean, I can use calculus to do it. You don't know calculus, but what if I had some formula that said, all right, it approximates, like say there was some value called the square root of 2, that's my fist, and you had some formula that kept dancing around it, but getting closer and 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 closer. So basically, you have some value that's too big, so you subtract off something, but then it's too small, but then you add something back that makes it a little bit too big, but you keep honing in on that value, right? So the more terms you add, the closer and closer and closer in value you get. It's kind of like you're tweaking your errors. Well, that's what these series do. Because of the nature of this negative, and you'll see it, I think, it takes a lot of time to write one out with all the ugly expressions. It's long enough just to find one term. But what you end up seeing is it hones in on a value and it lets you approximate things like root 2 or cube root of 3, or depending on how you set it up. We're not going to do any of that. We're just going to be finding the actual term. So, same mentality as before. I'll give you a couple warm-ups to make sure you're with me. And then we're going to move into actually having fractions up here and show you, because the math gets a little ugly, but most of the work's the setup, and then the math part I think you can do, but you just got to be careful. So, for example, but anyway, I'm throwing more than I need to out right now, just to kind of explain why in the world I would actually include this. Because it does have a link to the series that you do in BC Cal. And if you don't take BC Cal and you take Cal 1, then the Cal 1 will not explore Taylor and Maclaurin. We just don't get that far. It's more of a Cal 2 topic in college. And so if you went to a field that required you to have Calculus 2, which some do, a lot of curriculums do, then you would have to take that Cal 2. So you might see some of the stuff floating around. But anyway, here is a couple of things. Do y'all know what 0 factorial is? Everybody knows that's 1, and 1 factorial? Also 1? Okay, so let me just give you a little quick, we're going to do the setup, not the simplifying. We'll do the simplifying with the other stuff. But what if I were to give you something like this, and I said, find the 5th term. Tell you what, find the 4th term. You remember what you would do? Take that as a note. Okay, so the first thing you need to do on any of these problems is what? You can set all of these up by saying that number on the top with the factorial, and then whatever these two numbers are here, 2x, negative 3y. So whether I ask you for the middle term, the 4th term, the nth term, whatever, I can always start like this. Now when I say find the 4th term, what do I end up putting here? It's not 4. Remember that k value? If I'm looking for the 4th term, the k is 3. It's always 1 less than the place you're looking for. So if I'm looking for the 4th, the k is 3. That goes right there. And then what do you remember about these two terms? They have to add up to give me 8. So if that's a 3, that would have to be a 5 by default. And then what do you know about these two values you wrote there? They also go here, but they're factorials here. And at this point, that's the pre-cal. That's the pre-cal of this. So all you have to do now is know how to do the algebra of this. Not even the algebra, the math of this. So that becomes 8, 7, 6, 5, 4, 3, 2, 1. But the 5, 4, 3, 2, 1 would have canceled with that 5, 4, 3, 2, 1. And just left me this 3, 2 on the bottom. And then 2x to the 5th would be 2 to the 5th, x to the 5th in the numerator. And then this would be negative 3 cubed, which is negative. So I'm going to put the negative out to the front because it's an odd number of negatives. And then y cubed. And then I'm going to cancel everything I can, which is not much. So all I have to do now is multiply that 56 times that 32 times that 27. Don't forget the negative, and then whatever your variables would be. So whatever that ends up giving me, I'm not going to do the math right here, but that would be my final solution. Actually, I do have that. Negative 48,384. Negative 48,384, x5, y3. We good? So that's the gist of this. What if I said, find the middle term? Same problem. Find the middle term. What do I know about the middle term? I gave you a little trick, but you have to find the middle, you got to know how many terms there are. How many terms are there if the power is 8? 9. And if you forget that, remember when the power is a 2, when you square it, you get a trinomial, don't you? So when the power is a 2, you get a trinomial. When the power is a 3, you get like a, remember the Pascal's triangle, the 1, 3, 3, 1? That's 4 terms. So if the power is 8, there must be 9 terms. And if there are 9 terms, which one is in the middle? It would have to be the 5th, because you have 4 on each side and that 1 in the middle. So 1, 2, 3, 4, 5. And if I'm looking for the 5th term, what would my k value be? 1 less, 4. Well, if you think through all that, you go, oh, it's 4. Oh, well, then that also is 4. Oh, well, they're both 4. So whenever I say middle term, I just take that 8 and I split it up. And you'll never have a middle term if it's odd. There is not a middle term. So you wouldn't be asked that question. And then from here, you just do the math. And this one you can see would be a positive term, right? Because you'd have 4 negatives when you multiply it out. All right? So let me up the ante a little bit. What do you do now? Oh, let me just mention this. What would you do if I gave you this one? Sorry. X cubed minus and I said, what's the constant term? You know what I'm even asking when I say what the constant term is?
The number that doesn't have
the one that doesn't have an x. So I want at the very end all my x's to cancel and for me to have like x to the 0. Now I don't have to say constant. I could say, hey, find the term that has an x squared in it. And then you'd be figuring out what powers there would make me just have an x squared. Now in this one, you said there is no constant term. Why? Because if you were to expand this, you're going to start with like an x to the 8th here on the left, right? You're going to start with like an x to the 8th over here, and it would go x to the 8th, x to the 7th, x to the 6th, x to the 5th, all the way down to no x's. And you're like, oh, well, the no x's, that must be the constant. No, because you've also got y's, and the y's are y to the 8th on the far right side, and they're decreasing as you move to the left, where you have no y. So at some point, you always have some variable. So there is no constant term here. But there could be a constant term there if when you expanded it, it just so happens that your x's ended up canceling, which is possible because you have x's in the denominator and the numerator, right? And I would, of course, have to engineer this problem where it had a constant term. So how would you get started right off the bat? 14 factorial. Of course, you can copy these down. And you're looking for these powers. So I really don't have any clear direction like I had here. No immediate plan. It really is more guess and check and revise. But it's got to work, right? Where all the x's cancel, there wouldn't be a constant term. So anybody got any guesses?
2 and 12.
2 and 12. So if you're really good at eyeballing this, you might be able to jump right to it. But let me just pretend I'm not good at eyeballing. Let's just say I picked something like 10 and 4. I'm just guessing, right? So when I raise that to the 4th, I get x to the 12th. But what's a square root of x to the 10th? That would be like an x to the 5th, wouldn't it? Because x square root of x is like an x to the 1/2. So even if you wanted to change that to 1/2, it might help you see it. So if I did that, I would have an x to the 5th. Well, those don't all cancel. Now, if the question was find the term with x to the 7th in it, awesome. Because this ends up canceling and leaving me an x to the 7th. But I don't want x to the 7th. I want x to the 0, or no x's. So that was not a good guess. So I go, well, let me try 3 and 11. Well, that's a terrible guess. because that 11 is not even going to get rid of that fraction, is it? So then you go, well, let me try 2 and 12. And at some point, I go, oh, look, 2 and 12. That gives me x to the 6th in the numerator, and it gives me x to the 6th in the denominator. And once I see that my x's are going to cancel, then I can do the rest of the math. So once I'm confident that the 2 and the 12 worked, I bring them over here also, right? And I can cancel that and go 14, 13 over 2. But don't forget, I still have 2 to the 12th and a negative to the 12th. And a negative 2 to the 12th is positive, but does leave me this really big power of 2, doesn't it? But that's okay. I end up with the 2 to the 11th up there and a 14, 13. So I am going to have to suck it up and multiply 14 and 13 out. Also this 20, 48. But look, all the x's canceled. So whatever that ends up giving me would be my value. Y'all see it? So hopefully that's a good reminder to get you back to where you should have been at Algebra 2. Some of you guys didn't get this right in Algebra 2. Like a lot of you knew how to set it up, but you kept, like you'd look at this and go, oh, negative squared is plus, and you'd put a plus in there. Now, it's positive, but you're still multiplying all these things together. So at the very end, you need to have one term left. Like all of this ends up being one term. Don't end up with something minus something or something plus something. Because this is times, times, times. Y'all seeing that? And then just try to do the math and show the work. I try to make the numbers not be big like this, which is not hard. All I got to do on this problem to make it a whole lot easier, right? And then all of a sudden, all you have to do is multiply 14 times 13. So I can make these problems on a test where they don't require a whole lot of math, but at the very minimum, show your setup really cleanly and go from there. All right, so here's where it starts getting ugly. All right, and this is what you're going to see on your test, most likely. I might put one of these on there, but this is the new part. So what happens if I give you this? And I say, find the fourth term. All right. Anybody got any ideas? What can I always do on these problems? So I can always go, whatever's up there, 4/5 factorial in the numerator, copy those two things down. So 32x to the 10th, negative 2y to the 7th. So I can always do that. That should be a no-brainer on any one of these. Then you got to put your brain in here and kick in what you remember from last year. If I'm looking for the fourth term, then my k value, and I call it a k value only because there actually is a formula for finding these, and they call it the k value in most books. But the k value would be what? So if the k value is 3, that goes there, not here, there. Now, what do you know about this number? It has to add to give me 4/5. Now, some of you can do that in your head. If you can't do it in your head, set up a little algebra equation. I know that 3 plus this missing number, I don't know what it is, call it A, okay, has to add to give me what? 4/5. That's what I've been doing the whole time, right? Except most of the time it's been a whole number. These two things add to give me that. Well, same thing. Those two things add to give me 4/5. So what is my A value? Are y'all with me? If I subtract 3, I'm really subtracting 15/5. So negative 11/5. It's not pretty, but I don't care. Put it here. Factorial, put it here. And that's half your credit on a test, is showing me you understand the pre-cal of it. The rest of it's the algebra. But the algebra is going to take a notch up, okay? Now here's the beauty of all this. Because these share the same denominator, as I start expanding them, at some point, just like before, like you know how when I used to write these out, at some point, all of it canceled with the stuff below it? Same thing's going to occur. So don't start expanding this thing, just be patient and start expanding this thing. So let's do it. What is 4/5 factorial? It's 4/5 times -1/5. Does everybody see that? Because I have to subtract 1 from it. So times -1/5 times, keep going, -6/5 times, times -11/5. Now, at this point, isn't this continuing to go? So that is still a factorial. I'm just going to pause it there because I know it's going to keep going. I'm going to copy this part down. And look, since this keeps going forever, as well as this one, at this point, all of that cancels. Not too bad? Now, let's try to clean the rest of this up, because it's kind of a mess. What does -11/5 mean to you? Say it louder. Anybody?
The 11th power and the 5th root.
So it's the 5th root, and then the 11th power, or vice versa? But what does the negative mean? Put it on the bottom, or take the reciprocal. So here we go. I'm going to put it on the bottom, and I'm going to take the 5th root of that, 5th root of 32x to the 10th, raised to the 11th power on the bottom. And then the other part's not a big deal. It's just -2 cubed, which is -8. But since I'm multiplying all this stuff together, what am I going to do with that negative? Put it out front, and then y to the 21st. Now, it is no coincidence that I chose 32 and x to the 10th with that 5th root to try to make it nice. And for those of you that are thinking, wait a minute, do I do 5th root and then the 11th, or do the 11th and then the 5th? Well, what do you want to do? I don't know 32 to the 11th, but I do know that when I 5th root a 32, I get a what? A nice, neat 2. And when I 5th root an x to the 10th, I get a nice, neat x squared. And then with that, I could take the 11th power up, couldn't I? So, let's try to clean all this mess up. What do I have? I've got how many negatives here? 1, 2, 3. So it's definitely negative. What's in the numerator over here? Isn't this 4/5 times a 1/5 times a 6/5? That's gone. And then all of it's over 3, 2, 1, which is a 6 on the bottom. Isn't that 6 on the bottom the same thing as a 1/6? Are y'all tracking with me on that? So I just write these fractions out, and then whatever's left on the bottom, I write it as a 1 over that as a fraction. Kind of helps me think better. And then all I have over here is a 1 over a, what's 2 to the 11th?
2048.
2048. Way to remember your powers. X squared to the 11th. X to the 22nd. And then I have an 8y to the 21st. And that 8y to the 21st ends up being in the numerator here. And then at this point I start canceling. And look how kind I was. You may not feel like I've been kind so far, but check it out. That 6 cancels. How many 2's is that?
3.
That's 3. And that? 2 more. So that's 5 2's. What if I cancel those 5 2's with 5 of those 2's? How many are left? Since that was 2 to the 11th. 6 2's left, so a 64. So that ended up being not as bad as I thought. Now I end up, and I'll even show you another trick. I end up with 3 5's, 6 2's, So here I have negative, I have 3 5s. Sorry?
Like on the video.
Am I going to be in there?
Yeah,
You
you're
probably
good.
not.
No, you're good.
Am I?
Yeah, you're good.
Thanks, though. So I end up with 3 5s, and then I end up with 6 2s. So for those of you that don't really want to multiply 125 times 64, which is not that bad, but not wonderfully pleasant, anybody got any ideas? What could I do?
Assume position.
I know it's 8,000. Why do I know that? Because that 64 is an 8 times 8, and that 8 is a 2, 2, and a 2. And what do each of those make?
Nice 10.
Nice 10s. So I end up with 10 cubed with an extra 8. So I end up with y, that's probably not going to show. I end up with a y to the 21st and an 8,000 x to the 22nd, unless I made a careless error. And I don't know that because I don't have a key to this. Oh, and the negative. Thanks. Don't want to get dotted for that. Y'all seeing this? Now I'm going to move a little more quickly through the next one, but slow down when you're doing it. And remember, you're going to get half your credit just for this setup, at least, and then the other half is simplifying. All right, and the simplifying can get a little messy, although I really do my best to try to make the math have an opportunity for you to get there without being too tedious. But even if you don't see the little magic with the 5s and the 2s, and you went, okay, I got a 125 times a 64, you could go out to the side and multiply it together. It's not that big of a deal. All right, let's try one more. And that's really all I have, and tomorrow we're going to review, and then we'll test on Wednesday. And then I think we have one more chapter before conics, and then we're I think we'll call it a semester. All right, what about this one? So 8x to the 6th minus 3y to the 4th. All of that to the 2/3. Find the 4th term. So, how would you begin to set it up? So 2/3 factorial in the numerator, and then 8x to the 6th, negative 3y to the 4th. And if I'm looking for the 4th term, then what? K is 3. 3 goes there, not here. And if a 3 goes there, what do I add to a 3 to give me 2/3? Negative 7/3. Y'all with me? So a negative 7/3 goes there. And if those two things go there, they also go here, but with a factorial. Half credit for that. The other half is the math. So what is going to magically happen with this 2/3 as you begin to expand it? 2/3 times what? Subtract a 1, negative 1/3. Subtract a 1, negative 4/3. Subtract a 1, negative 7/3. And at that point, what happens?
Cancellation.
It cancels with this negative 7/3, which was also getting expanded. And again, I put dot, dot, dot in there, but the math of it would be, those are still factorials, which means they now cancel. Don't forget this 3, 2, 1. And then how do I deal with that? What does a negative 7/3 mean? The 3 means the what? The cube root of 8x to the 6th. Then raised to the 7th, the negative tells you it's in the denominator. And then times, what's negative 3 cubed? Negative out front, 3 cubed, 27, y to the 12. And at this point, we're just cleaning junk up. So what am I going to do? 3 negatives ends up being a negative. I'm going to write these fractions down. 2/3, 1/3, 4/3. That didn't get canceled. That 6 on the bottom ends up being a 1/6. What is the cube root of 8x to the 6th? 2x squared. That gives me a 2x squared to the 7th. What's a 2x squared to the 7th? I'm just going to write for now 2 to the 7th, x to the 14th. And then that ends up being in the numerator 3 cubed y to the 12th. And if you did that cleanly, you'd have at least 3/4 of your credit. And the last thing would be to just cancel and hope for cleanness. What do I have here with this 2 and 2 more 2's? That's 3 2's, right? Couldn't I cancel 3 of those 2's with 3 of those 2's, leaving me 2 to the 4th, which is a simple 16? And then couldn't I cancel, like how many, this 6 is a 2 times 3. Couldn't I cancel, well, I don't even need to do that. I'm going to leave that as a 6. Couldn't I cancel those 3 3's with those 3 3's? So all I have left is a 6 times a 16 on the bottom, an x to the 14th along with that on the bottom, and a y to the 12th in the numerator. And then again, don't forget that negative. You see how I can get the numbers? They clean up pretty nicely at the end. I'll try to do that. The only way that wouldn't be that way is if I accidentally make an error on my problem. And sorry. Y'all with me? All right. Good to see you back. Y'all have a good one.